Hey there, in this video we are talking about classes and object-oriented programming in C++, and this covers sections 13.1 to 13.3 in the Gaddis C++ book. And this is such an important section. You know, this actually might be among the most important sections of the entire C++ course. We have been working to prepare for this for a long time. Let me reflect again on the name of the Gaddis textbook that we use all the time. You know, it's called Starting Out with C++ from Control Structures Through Objects. And here, we're finally getting to work with objects for the first time. So this is it. We've finally arrived. And for my students, if they look at the syllabus, they'll look at the list of course objectives. And the number one top objective of the course all along has been use object-oriented programming to organize data and functions together. So we have finally gotten to this top number one objective all along. You know, this has really been our goal at CUNY Kingsborough almost an entire year of computer science courses. All this preparation, all these building blocks that we put together, we're finally get to put them together in one single unit, and we'll get to see how modern programmers really do their work. So I've been waiting for this for a long time, and I'm so excited to get into it. So let's think about the difference, how our programming is going to shift as of right now. So up until now, the whole Programming 1 course, up through this Programming 2 course that we're in currently, has really been about procedural programming. And remember, procedure is basically a synonym for the word function. You can basically, when you see procedure, you can basically think of a function. So procedural programming considers your data and your functions to be separate entities. When we've been designing our programs in class together, we've had one phase where I've said, let's design the data. What are the structures going to look like? What kinds of data? What types will we have to use? And then as a separate phase, we've said, now what kinds of functions do this program need to do? And we probably design some function prototypes together. Okay, and then you go actually write the code. But the data and the functions are two separate entities. And most of the time that you're working, you make your data up front. Most of the time, your focus is on the flow of the function calls. How do I call my function? What happens in the function? What order should the functions be called? Stuff like that. Now, the big transition, and this was more or less invented in programming in the late 70s, early 80s, is what's called object-oriented programming. Very, very common. Most programmers are working with this paradigm in their head nowadays, so we use OOP for short for that, is where you combine your data and your functions together into a single entity that we call an object. And there's so many advantages to that. So you have this one single unified entity that represents a particular thing in the real world. And you'll have your data, which represents qualities of the object, and you'll have functions which represent things that the object can do. And it'll be a lot more conceptually coherent about really what you're thinking about, what you're modeling in the real world. It's going to be more secure in a lot of ways. If you have a big team of programmers working together, there's a whole lot of security elements that prevent one programmer from accidentally screwing up another one. And the objects will be doing a whole lot of work kind of automatically under the hood that takes care of a whole lot of initialization and destruction and cleanup issues. And all that stuff's kind of automatically going to happen a lot of the time. So many advantages when you put together all these ideas in what we call object-oriented programming. All right, so here's the basic idea of the object-oriented paradigm. And there's this picture on the slide right now on the right. And you know what? That's actually from the Gaddis textbook, Chapter 1. If you look all the way back in Chapter 1, this picture was there, kind of giving you a sense of what was going to happen in the future. Is our goal all along has been to get to object-oriented programming. And they totally clued us into that way back in Chapter 1 with this picture here. So what is an object? It's a combination of data, variables, and functions to represent one conceptual thing in your system or the world. So one object could be a window, or it could be the keyboard, or it could be a person. It could be a student, it could be a car, it could be a pet. So something that you care about in the real world is represented by one single object. Now, before you actually make an individual object, you have to make what's called a class, which is a format for objects of a certain category. Class is basically a synonym in English for something like a category. So a class is very much like a struct. Okay, so in our sequence, we learned about structs back in chapter 11 that packages a bunch of data together. So classes are very, very much like structs. They're basically structs, except in addition to data, it's also got functions inside it. Fundamentally, that was the big innovation with object-oriented programming, is take the idea of a struct, but then add functions. It's got both data and functions inside the class. And then when you instantiate, when you make one of those things actually in memory, we call that an object. So this picture over here, it's labeled object A. It's going to have some variables. It's going to have its own variables for data storage, just like a struct does. But the new thing that's being added in addition to that is it also has some procedures or functions. Again, in C++, we would call these functions. So you have procedure or function A, just like we've dealt with before. Of course, that function is going to have some local variables that only have scope access inside that function. That's not changing at all from what we've been doing. And then you'll have some programming statements that actually make things happen, and there's the end of that procedure. And then here's procedure or function B, and that'll have its own local variables and its own programming statements, and obviously there's the end of procedure B. So the object has some variables that you can access throughout these functions, right? These object variables will have scope throughout all the functions of the object. They can all access that. And the functions will also have their own local variables that are only usable within the functions, just like normal. Okay, so that's the basic idea. Very much like a struct, if you remember what that looks like. Objects have variables and they also have functions inside them. Great. Okay, so assuming you want to do that, what's that going to look like? Objects are created from what's called a class. Class is a keyword in C++. It's going to show up in boldface in our IDE. And so the format is you're going to say, here comes a class, give it a good name that describes what kind of thing you're describing. We usually make that singular, right? So the class name could be cat or window or car, right? Singular, not plural. We're making a new type. So as usual, we're going to start with a capital letter. Other than that, it's camel case is what we normally do. And then curly braces and then some declarations here. So hopefully that looks a whole heck of a lot like a struct definition. The difference here is that these declarations can be data, but they can also be now function prototypes because you've got both data and functions inside your class. Other than that, very, very similar to a struct. Let's see an example of that. Okay, so here is the first class example in the book in chapter 13. So we have a class called rectangle, capital R rectangle, obviously. Very, very common class when you're doing Windows programming because your windows and your menus and your frames and your pictures, they're all in rectangles and you have to keep track of how big they are and where they're placed on the screen. So this is actually a very common element in graphics programming, as a matter of fact. Not surprising you would want this. So at the top here, you have some data. Right? So I have a double called width and I have a double called length, and those are the primary things you need to record to know how big your rectangle is, obviously. So there's variables to store data in each object, just like a struct. But the new thing here down at the bottom is here's a bunch of function prototypes, functions that each object can perform on itself. You've got these functions called setWidth and setLength that are going to be changing the data in the member variables. And then you also have functions like getWidth and getLength and getArea, which are going to report to the outside system how big the rectangle currently is. This is a very, very common setup. And if you do more object-oriented programming, you're going to see this hundreds or possibly thousands of times like this. Now, the other thing, obviously, that's new here is that you have these different sections with these labels private and public. And you notice that what's happened here is all of our data has been put in the private section, but all of our functions have been put in the public section. And we'll be talking about what that means a lot more later on. But by default, you should expect this to basically always be the case. Okay, so if you don't, we'll come up with some exceptions later on. But as a starting point, you should expect that all your data is in the private section and probably all your functions are in the public section. We'll come up with some exceptions later on, but this is what you should expect as a starting principle. What does that mean? Well, it means that the stuff that's private can only be accessed, is only in scope within the class. But the stuff that's public can be accessed and can be called from outside the class, like maybe a main function or some other function, or maybe another class entirely. But the private stuff is only in scope within the actual class object. Okay, we'll be talking about that. Like, I think the next video is mostly just giving more detail about that aspect, but there's an introduction to those two sections. Now, among the things in this class, on the next slide, I just kind of want to focus on a couple things, because obviously we haven't implemented the functions yet. These are just function prototypes. So further down the code file, we're actually going to have to give code that actually defines the member functions. And the two things we're going to focus in on the next slide is this member variable width. Okay, so there's a double precision floating point variable here called width to store the width of the rectangle. And I'm also going to focus on the very first member function that's called setWidth, right? It has a return value of void, it's called setWidth, and it takes one single double. Let's go see what it looks like when you actually implement that in the code. So following those prototypes, following that class header where you have the data and the prototypes being described, now your member functions actually do have to be implemented with actual code. First thing is that the full name of these member functions are going to be class name : function. The name of this function is not just setWidth. If you see this example down here, technically the full name of that function is capital R rectangle : setWidth. That's really the first and last name, I would say, of this member function. So you have to be aware of that, and you're going to see that in the function implementation. We've seen this : operator before. We've been using that like in chapter 12 for file handling. We were seeing that a lot. iOS : in, iOS : out. Remember, if you don't use using namespace std, then technically the full name of the functions for sin and count are std : sin and std : count, and std : endline too. Right? So these things are actually part of a larger class or a larger library scope. And some of the times, if you're using namespace std, you can mask that or just take that for granted. But here we really have to be aware of the full name of our functions. Is here's your class, scope resolution operator, here's the name of the function. Now, when working inside a member function like this, as we said on the prior slide, the private member data of the class is in scope. It is accessible to your code. But outside of the member functions, that private data will not be accessible. Okay, that's an incredibly important point that we'll continue to come back to time and time again. So hopefully you remember, so here's this rectangle setWidth function, and clearly someone's going to call this. The goal here is to set the width member of the rectangle. So in comes a double that we're calling W here for short. And obviously it's a very, very short function here. It just sets width to that W number. So hopefully you remember, right, width, if you look back at the prior slide, width is the first piece of member data in the rectangle class. It's an object variable. And previously, if that had been a struct, like back in chapter 11, hopefully you would expect to access a member variable like something like struct.width, right? We were doing that a whole lot back in chapter 11, chapter 12, struct.width. But here, when you're working inside a member function, conceptually, you're inside the object. Well, you don't need to write the struct dot or the class dot or whatever. You can just say width, and we know what object you're talking about. It's the one that you're actually inside of right now. So here, that member variable width is being set to that incoming W number. Okay, and then the width member variable has been updated with the new width. So let me just emphasize that. The width member is private. So it is in scope inside a member function like we're looking at right here, one of the member functions of the rectangle class. But if you try to access width, say in the main function, which is not inside the class, that's not going to work. It's outside scope. Private member data only has scope inside the class functions. So here, this line 25, this is legitimate, but if you try to access it from someplace outside of the class, that will not be permitted. And that's a major security feature of object-oriented programming when you're working with really big teams. Only the person who's working on the rectangle class gets to actually access this. This right here is one of the most important slides of all. Like, I would really recommend that you pause the video or you look in the book at this section or get my lecture slides. If you can understand what's happening on this slide right here, you are successfully starting to understand object-oriented programming. That right, ridiculously short function, obviously, but if you really truly understand what's happening right there, that is the most important beginning step to object-oriented programming. Okay, but of course there's more. So at this point, we've defined the class, but again, that doesn't actually use any memory. Now we actually have to create an object, just like when you create a variable from a struct, right? So objects are variables and classes are like structs. So a class defines a new type. So based on the prior slides, in addition to int, float, char, bool, and like maybe student from the past, now we have the type rectangle. And you can declare variables of that, or technically objects of that. Objects are variables declared from that new type. And the language that we commonly use is we say we're instantiating a class, or we say that an object is an instance of a class. And to be clear, in English, instance is a synonym for like example. Okay, so you could say we're coming up with an example of a class. One single object, one item out of this class. And again, class in English is a synonym for something like category. So you can think when we're making an object, we're making one example out of the larger category of rectangles. There's a whole lot of rectangles in the universe. I mean, that's the class. And when we come up with one single rectangle, that's one object. So here we are doing that right here. You're defining objects just like you do other variables. You put down the type, which in this case is rectangle, and then you come up with hopefully a good name for your object variable. Here, the book is just naming a rectangle lowercase r. As I think you know, I would personally never make a variable just one single letter. I would want to call this maybe like rect, like R-E-C-T would be better. Or you could even make it rectangle lowercase r would be fine. Like a lot of people usually say rect, frankly. We should have put that on the slide. But anyway, here we have one variable. It's called r, but it's of type rectangle. And now, having had that, just like with structs, now you can start accessing the public functions using the dot operator. So here I am calling that function we saw in the prior slide. Here's r.setWidth. We're passing in 5.2, and I know that internally that's going to get saved in the width member variable of the object. And then here we're calling r.getWidth. And I know that what that's going to do is look up the current value of width, return it, and then this line's going to print it to the screen. So you can use those return values any way you want for arithmetic or math or printing or whatever, or save it in a record or save it in an array. So there we are accessing, no big surprise, right? No big surprise that you're going to access the public functions using the dot operator just like you do with structs. And I mean, we've been doing that all through chapter 12, right? When we were doing file handling, file.open, file.close, file.read, file.write, right? File streams in chapter 12 are classes. They're object-oriented. And they contain all these different functions that we were accessing all along using the dot operator just like this. It's just that now we're getting to create our own classes instead of just using file streams and strings and stuff that other people wrote. All right, so here is the first program in the book, and the programs are going to get a little bit longer now. I mean, that's actually why you want object-oriented programming in order to organize all this kind of complexity. So here's the very first program that uses that rectangle class here for a couple things. So just as we saw there, here's the class definition, the class declaration here, lines 6 through 17. You've got your private data for the width and the length members. And then you have these public functions, set width, set length, get length, get area. And then below that, you're going to have the definitions of all those functions. And we've seen rectangle set width before. Taken a double called W, and then just record that in the width variable. And remember, width is this thing that's declared up on line 9, right? That's one of the object variables that's inside the class. And since it's declared here, width does have scope in any of the member functions inside this class. So you can access that in any one of these functions, right? And here we are accessing it here in the set width to actually record a new number there. Great. And the next thing we're going to see is set length. It's going to be very, very similar. It's going to take in one double value, and I'm sure it's going to set it in this length variable right here. Let's go see that. Yeah, of course. Okay, so in comes a number we're calling len, and we just record that in the length member of the rectangle. Super. Now here come what are called the accessors. We'll talk more about that next time, but these getter functions. So here's rectangle get width, and all it does is it looks up that width member variable of the rectangle and just returns it. So somebody that doesn't know what the width is, they can call this function, find out how wide our rectangle is. Here is get length, does the same kind of thing for length, right? You don't need any parameters for that. It's just going to look up the current length member and just return it. And then you can print it or use it or calculate with it or whatever you need to. Very, very simple. Notice these const labels. We should talk about that in a second. Now here's get area. Now get area has to do a little bit more work. Obviously, the area of a rectangle is the width times the length. So anytime someone calls get area, we're going to look up the width, put that in the CPU, look up the length, multiply them together, and return the result. And this will be reporting on what the area of the rectangle is. Okay, no big surprise about that. Notice that we don't have a separate member variable for the area. In this case, you just recompute it anytime you call get area. And maybe that's good, maybe that's bad. We'll talk about like optimizing that later perhaps. So here is the main function where we're going to test the rectangle class. And probably the single most important thing here is on line 70 is we're declaring an object, right? The type is rectangle and the name is box. So there we are defining an instance of the rectangle class. That's really where all the data that we're interested in is going to be stored. Now this program does do user input with sin, so you need a couple variables just to receive what the user's typing in initially. So we have a double for rect width and a double for rect length just to receive the sin results. Here comes the user input part right here. Prompt the user, the program's going to calculate the area of a rectangle. What's the width? And you sin into rect width, okay. What is the length? You sin into rect length. Not too interested in that, that's just old stuff. But here we are now calling, on line 83, 84, we're calling the member functions of that rectangle called box. So on line 83, we're calling box.setWidth, and we're passing in that rect width variable that the user just told us about. So of course, as we saw before, that number is going to come in and it's going to get saved in the width member variable of the box object. And then here's line 84, we're calling box.setLength, calling that particular function in the object. Going to pass in rect length, and we know that internally that gets saved in the length member field of the box object. Okay, so not too surprising about that. You got to call the setters there to actually set your data. And now we'll see some results on the next piece of the program here. Here's the output part of the function of the program. Here's the rectangle's data, and you're going to print out the width, and of course you have to call box.getWidth to get that. And we saw that just looks up width and just returns it. So you'll see it on the screen. And here comes the length, and you call box.getLength to see that. And finally, here's the area. Notice that me working in the main function, I don't need to see the multiplying. That's hidden on me. It's all taken care of because all we have to call now is just box.getArea, and that function does the math and returns the result, and you see the area. So the book is asserting that if you run this program and put in this input in boldface here, it's going to say this program will calculate the area of a rectangle. What is the width? Let's say 10. And that gets saved in width. What is the length? 5. And then it's going to say, here is the rectangle's data. The width is 10 and the length is 5 and the area is 50. And that is correct. Of course, we should test this on our own to be totally sure about that. And here is this program 13.1 for us to test here. As usual, I've put this in a dedicated folder. I really like to have one particular project in one folder to organize it. We've been doing that all the way through chapter 12 with file handling. And I'm glad we've gotten into that habit because like in the next video, we're going to start having a ton of different files running around for one single project. So that's a really good habit to be in right here before things get too crazy, frankly. And I've loaded this program up in the Dev C++ IDE as usual. Now hopefully that tab that we've been looking at occasionally called classes makes more sense. This is the tab that's going to keep track of all your different classes, which is among the most important things in a C++ program. So here it is defined in the actual code. It's called rectangle. We have these two pieces of member data, width and length, of course, plus all those public functions. But if I'm working in some other part of the code base, I can just look over here on the classes tab in Dev C++. I can open it up and you can see it actually lists all the functions first. Get area, get length, get width. Here's the return type. And then it lists the private data last. And it's tagged, if you can see that, it's a little bit small, but it is tagged PRIV for private. Kind of remind you, that data there is private. Don't forget about that. So there's all that stuff, and here's the definitions again to all those functions, what they do. Here's the main function, which asks about a rectangle, stores the data, prints it back out. Let's compile this. And of course, there's pr13one.exe that just showed up in Windows. I can close this. We'll run it at least once. So the program will calculate the area of a rectangle. What is the width? How about 7? What is the length? How about 9? And it writes out, here is the rectangle's data. The width is 7, the length is 9, the area is 63. And of course, that's correct. Okay, then, normally I would test that at least 2 or 3 times with, make the width larger, make the length smaller, stuff like that. But obviously this is working, right? And what it's successfully doing is it's recording the 7 and the 9 inside the box's member data of width and length with these functions. It's successfully retrieving that data using the getWidth and getLength functions, and it's also successfully computing its own area with the getArea function. So that's exactly a whole bunch of stuff that's happening internally inside the box object automatically. So hopefully that makes sense. But let's do something else. Okay, so we know that the width, as one example, is one of the pieces of member data in the rectangle class. You can see it here in the actual code. You can see it over here in the classes tab as a reminder if you need that. So let's say I'm another programmer and I'm coming in here and I've been tasked to add a little bit more code to this. Here is the, what I want to do is I want to print the width again. It's not the most interesting thing, but let's say I want to print the width again. So I should be able to print out width, right? And if we were working in chapter 11 with structs, how would you get at the width member? So hopefully, back in chapter 11, we were usually writing struct dot, whatever your member data actually was. So perhaps you would expect to be able to do this, right? Box dot width. Okay, we absolutely know that width is one of the member datas in the box object. No question about that. So shouldn't I just be able to do that? I can just see it right here, right? Let's see what happens when we try to make this happen. So I hit compile, I get an error. And it says that double rectangle's width, and of course that's the full name of the width really. The full name is really rectangle scope resolution operator width, to be perfectly clear. Well, that particular width variable is private within this context. See, that's what the private really means, is you are not allowed to access it from outside the class. The width double, that particular width variable, is only accessible within the functions of the object. So you can access it up here because that's a function that's actually inside the class itself. You can access it here because that's a member function, so that's all permissible. But if you try to access that from outside a rectangle function, it's not permitted. And that is the security feature. That's the primary security feature of object-oriented programming, is you're another programmer working in another part of your massive, huge 10,000 line program. Well, as a security feature, you are not allowed to directly access the width member. It's private. It's only accessible inside the particular object. So we know that what you are allowed to do, just like up on line 88, is you are allowed to call one of the public functions And the way that this is set up, that's actually the only way that you can get at the with member. So you are allowed to call get with because that's not private, it's public. So that's why this here actually works. And now if I run this again, you'll see that with get printed twice. I'll do 5 and 10, right? And that is the line that we just added right there. So that's what the private is doing, is it's marking part of the class that you're not allowed to access from outside the object, outside one of the class functions. So again, we'll talk more about that in another video. We'll keep thinking about that, but hopefully that helps to understand what's actually happening there. All right, one more thing. In that code, one little detail there is that some of the getter functions, I guess actually all the getter functions, were labeled with const at the end, and we know that means constant. So in object-oriented programming, what that means is if you have member functions that are tagged with this keyword const, and we saw that there, we saw double get with const, it indicates that the function is not supposed to change any of the data in the object. So that's one of these security features in object-oriented programming. You tag it like this, and the compiler is going to enforce that. If some other programmer is working inside that function and attempts to change the member data, like the width member or the length member or really anything, the compiler is going to refuse to permit that. It's not going to compile and will give you an error of, hey, this is supposed to be a const function. This is how the function was set up. You are not permitted to change the data from here. So technically that's optional. You can have everything working properly without that. But again, it's good practice on a big team. If I have Alice working on the program and Bob working on the program, Alice will probably tag her getter functions with const to tell the other programmers, hey, this is a function that's not supposed to change the member data. And if Bob is kind of hazy about that someday, the compiler is going to enforce that rule. It's going to tell Bob, wait a minute, we agreed this function doesn't change the member data. So a really good additional security principle in object-oriented programming that doesn't exist in procedural programming. So one more advantage like that. I like that a lot. So if you're in my class, if you're one of my students, the next thing would happen is we'd get together for this first lab in chapter 13. It's called the Square as a Class lab. So we have some starter code in square.cpp for a class to represent squares, obviously. And we're going to fill in the code to define this class representing a square and use one of those objects that automatically computes its own area and perimeter. So we'll have to, again, the code file is going to be a little bit bigger than before. We're going to have to read the whole code file to get the function prototypes synced up with the function implementations, but hopefully that should be pretty clear enough. So a good beginning to object-oriented programming, I think. Again, if you can see what's happening, particularly that example with the set width function right there, look at that very, very closely. And if you can understand that, you've taken the first quality step to how your programming is going to look differently when you're doing object-oriented programming. So I'm so happy we finally get to this point. And everything else we talk about for the entire semester is going to be in the context of object-oriented programming. So we'll get more details and more features and more options and more things you can do with object-oriented programming. But probably for most modern programmers, this is what your program is going to look like forever, from now on forever. So all this class and probably your future classes will be like this. I'm so happy we finally got here. So when we come back next time, the thing I want to talk about is I want to give a little bit more detail to those issues of the private versus public sections of a class. So important, such an important part of the security policies of how object-oriented programming help you organize your team clearly. So next time we'll talk more about those issues of data hiding and also separating our specifications out into multiple files because our programs are getting bigger and bigger. So we're going to start not just having one .cpp file, but we're going to have to start splitting it up into multiple files. And then again, when we're working on a big team, now you can give one file to Alice and one to Bob and one to Kathy. And that's actually how you split the work up among team members. So we'll get a little bit more insight to that next time, and I'll see you then.